Okay, I see, and I see you can hear me, so that's good. Okay, so I'm Maria, and I'm here today with the pleasure of presenting you FawltyDeps. Or do I have the pleasure of presenting you FawltyDeps? Yes, not this one, but another one, FawltyDeps. That is a dependency checker. I encourage you strongly to check out GitHub repository, which is well documented. There is a lot of stuff about architecture, how we did it, what we did there, and also our introductory blog post in Twig blog. There is a lot of written information if that's the better way for you to parse the information. Okay, so the inspiration for FawltyDeps were several user stories, so several stories that we encounter as developers. First is imagine that you want to run someone else's data science project. Those are usually notebooks. So after 20 minutes of training, the notebook crashes because in the next cell it tries to import something that you never installed in the virtual environment you're running it in. And that is because you did not know that dependency was needed there. Another example, and that's actually the one that inspired us the most because it was close to what we did for our client, is that we had to productize our client Python scripts. And those scripts were not perfectly specified with dependencies. That is why it was a bit of friction point for us. So basically we did FawltyDeps a bit for ourselves, but as an open source project, so everyone are encouraged and invited to use. And another story is on the other side of problem. So imagine that you tested something in your virtual environment and you added a big library like TensorFlow to your requirements. And later you did not use it because not. But you forgot to remove it. And every time you run CI, this library is downloaded. I know there are caches, but anyway, it's a heavy library that you do not want to be in your virtual environment because it's too big then. So before we go into how FawltyDeps solves those problems, I would like to say a few words about Twig and the team who worked on this project. So Twig is a consultancy. Oh, where am I? Okay, I'm in a good place. Okay, so Twig is a consultancy company and an innovation laboratory, and we Twiggers care very deeply about reliable software, and thus our mantra is, okay, sorry, it just did not click the right moment. Functional, typed, and immutable. And I know that those values are not fully in sync with Python values, but we still think they are a good compass how to write reliable software that can be later easily used by other people. So for example, the typed value, all of the FawltyDeps code is type hinted, and it saved us a lot of trouble during refactor. It also worked as a documentation and made the code more readable. Okay, and the team who worked on it is Nur, who was the original idea from, and afterwards Johan and I joined her. With Nur we had a bit more data science background. Johan is a seasoned developer, so together we made a very, very good team, and we enjoyed working together, and I hope the fruits of this work you will enjoy as well. So, what now? Okay, so we have one goal, and we want to do it like in Unix philosophy. So this project, this tool that we provide must do one thing and do it well. So it needs to find unused and undeclared dependencies in a Python project. And just to be on the same page with everyone, what unused and undeclared dependencies mean. Let's take a very simple example of some Python Python file and requirement file. So Python file, it just imports two things, Django and leftpad. On the other hand, we declare that we want to use from external libraries leftpad and click. So Django was never required from us, so this is undeclared dependency. And click, which we said we want, we never used, so this is unused dependency. Okay, so exactly what FawltyDeps is, where to put it in the landscape of other tools like that. It is a dependency checker, so it is a bit like linter, but not a linter, a bit like type checker, but it does not check types. It checks different area of our Python project, so it checks if the dependencies and imports match. And it is a command line tool, so you can simply run it in your terminal. It is compatible with Python version since 3.7, which was very important for us because a lot of data science projects that you want to run or some older scripts are written for older versions of Python. We didn't want to go as far as 3.6, but still we are not very happy that we cannot use pattern magic, for example, because we have to be compatible with 3.7. Anyway, it is working on those versions. It is available on PyPI, so you can simply install it like you usually do stuff from PyPI. We cared a lot about quality of our code, so it lives up to all standards of good Python code, although it is functional because Johan was very keen on writing lazy, functional Python, and yes, it works. So it is linted, formatted, type-checked, of course, as I mentioned, and tested in many different ways. Unit tests, property-based tests using hypotheses, and our integration tests are also very interesting because they use both synthetic and real projects that are downloaded from GitHub. But the tool wouldn't be any good if the users could not use it. So that is why we put a lot of effort into documenting what we did and why we did it like that in GitHub documentation. And also, if you type FawltyDeps --help, it will give you all the options available for you in a very very nice way, in a very organized form. And another thing, if you ever want to join us in those efforts of developing FawltyDeps, developer experience is also taken into account. We combine Nix and Nox for testing, linting, and so on, because it is very easy with Nox to set up tests for different versions of Python. And in fact, this particular line could make a whole presentation because it's a very interesting thing to have. Okay, so we know what FawltyDeps is and what problems it answers. Let's see how it is made, what's inside. And now those will be two slides on the light background, the rest will be on dark, so don't worry. The things FawltyDeps consists of are three parts: imports, dependencies, and mapping modules. Because for understanding what are our imports and dependencies and to check what are undeclared and unused, we have to first understand what we import in our Python project. Imports are usually in .py files or in the notebooks, and we parse both. Dependencies may be in few different files, like requirements, setup.py, setup.cfg, and pyproject.tom. So all of this is covered. And the mapping, that's maybe the most interesting part, because in Python, when you have a library, it does not have to match, the name of the library does not have to match the thing that this library is exporting. So, for example, if you have scikit-learn, you declare in your requirements that you want scikit-learn, but if you import the scikit-learn inside your project, you write import sklearn. So you have to have some way of matching those two that you find in your files, the imports and the dependencies. And FawltyDeps allows you to do those operations separately. So for example, you can just see what imports are in your project or what the dependencies are in your project, but the default behavior is to find unused and undeclared packages. Okay, so let's go first into imports part. The three ways we usually import stuff in Python are from something, import something, or import something as something. So we give some alias to our import. We can also give this alias to our function. Okay, so we can now up5 ourselves and be very happy that we managed to handle imports. There is abstract syntax tree module in Python, so we can easily gather those things. We did not expect that. What did we not expect? For example, conditional imports. So depending on, in that case, this is a code from, even from FawltyDeps itself. So depending on the version of your system, of your Python, you can have the object imported from different libraries. So in here it's typing or typing extension. And in FawltyDeps we approach it so we want to have both of them declared, because your code should work for different versions of Python, and if it does, then all those things, all those libraries have to be declared, so both typing and typing extensions. But it goes worse. You have import lib library, so you can import stuff in Python as with usage of a function, import lib module. And in argument of this function, it can be anything you really want. So this part is, in fact, unsolvable with static analysis, because you have to run it to understand what's in it. You have to evaluate it. And depending on your system, your environment variables, it can produce you different kind of results. This particular example is very simple, but you can imagine that the argument may be something totally different. Okay, so those are the imports. So you see, the problem is stated very simply. I want to find my unused and undeclared dependencies. But in fact, the solution of this problem is not that simple, because every time you look how to gather some information, you end up in different paths and different rabbit holes. So each of this is a bit of a rabbit hole, and we had to say, well, let's stop in here. So in case of imports, we stopped at import lib. And for dependencies. First is requirements.txt. The upper part is what you usually declare. So the name of a library plus the version or the boundaries of a version. But in requirements.txt, you can also reference other requirements. And you can also reference other constraints. So to parse this one, it's not simply parsing the file line by line and taking the name of the requirements from it. Another file you can use to declare your dependencies is setup.py. And in setup.py there is a setup function, and in setup function there is a field install requires. Those are the main dependencies of your Python project. And in here, this is pandas and click. Just to remind, we try to do the static analysis of the code, so we do not want to evaluate anything. But AST will not help us, not directly help us, if we do something like that. So the requirements are a list which is named under requirements. So for this kind of situation, we do have limited evaluation, so we do not want to go deeper than the list of or the dictionary that we put into install requires. And of course, again, as this is a Python file and Python function, this can be whatever. This can be a Lambda function. Yeah, you can imagine. Okay, so next thing is setup.cfg. I did not see that a lot, but maybe you use it. Someone uses setup.cfg? Oh, yes, there are some people. Okay, great. So for setup.cfg, the syntax is a bit similar than it is in requirements. You just have to, it's like between requirements and PyProject Tom, in my opinion. So you just put what you want to install in install requires and then go with it. And we also support this format. And the most used right now, I think, who uses PyProject Tom? Okay, so who uses requirements? Okay, so it's like more on the requirement side, I see. Okay, that's good, that's interesting. But the fourth option of our dependencies, where they can be placed, is PyProject Tom. And in here, also we have several options how to do that. Usually, if it's like a vanilla PyProject Tom, you put the dependencies under project in dependencies, as I highlighted here. But if you use Poetry, you do not want to do that. You want to put the dependencies under Poetry dependencies. And all those examples I show you are to prove that even though it's a simply defined problem, it has a lot of things to be taken care of, a lot of different paths. Okay, and the third part of FawltyDeps is mapping. So as I mentioned with the example of scikit-learn, similar thing is with PyYAML. So PyYAML, the requirement that you put in your requirements.txt can expose YAML. So you do import YAML. But that's not the end of the story. Some libraries, like in this example, Google API Python client, can expose more than one libraries. So from Google API Python client, we have API client, Google API client, and so on. All those informations are available in a file. When you install it in your virtual environment, there is a file called top-level.txt. And all these informations are available there. But unfortunately, they are not available from PyPI, even though PyPI has an endpoint to inquire about the libraries, the packages. And how we handle that? For this, we have a resolver stack that in order, it's like a funnel. You try from top to bottom and try to match your package with the thing it exposes. So the precedent over everything is taken by user provide mapping. So if you as a user say, my PyYAML is mapped to PyYAML, then that's the truth. Whatever is installed in your virtual environment. Then the second stage of this funnel is to check if in this project there are some local environments. You can pass it via one of the command line options, or you can just simply add it in a base path. And that is checked. So if you have virtual environment in your project installed, it will check. It will check if the PyYAML is there. If that will not succeed, it will go down. So FawltyDeps' own environment, so the one that you run FawltyDeps in. You do not have to run FawltyDeps in the same environment that you want to inquire. And the last thing that we recently added is to install PyPI package in a temporal virtual environment and check if we can get some mapping from it. And if all of that fails, we go to identity mapping. So we say that PyYAML is PyYAML because that's the same name. And we say Google API Python client exposes Google API Python client. Okay, and that's how this stack works. So just to remind what we want to achieve here is to find unused, undeclared dependencies in a Python project. So let's do the demo. Not really. Now I will do the demo, but I have it on slides because the live demo is doomed to fail and I do not want that. So I encourage you all to try FawltyDeps on your project and contact me via LinkedIn. It's the same name. My name is Maria Knorps, so you can find me easily, or just contact us via GitHub issues. And the best thing that you will find will be posted, I don't know, on LinkedIn, for example. Because we always are very happy when the FawltyDeps finds some missing dependencies, because that's the whole purpose. But also, we are open to critique and suggestions. Okay, so for this demo, I chose Peppy package. You can do it in parallel with me if you want to. Just git clone Peppy package. This is an official Python package for reading PIP in Python. So on the right side, I posted the structure of folders, how it, in general, how it looks like, what we can expect from this project. So first we want to understand where are our imports and dependencies, where can we find them? Okay, so we suppose that our imports may be found under Peppy directory, that's the usual structure, maybe also under tests, if we want to check if we do not import something weird in tests. And our dependencies may be found under requirements directory, setup.cfg and setup.py. So let's start with those dependencies. Okay, setup.cfg is only what you see here. So nothing interesting, only some flags for PyTest and some alias. Setup.py, on the other hand, is a bit interesting, but still it does not expose requirements to us. It just says that take requirements-all from requirements folder. So it's again something that we will not be using. And what can we find in requirements? As a title of slides, there are usually commands that I run to get the slides content. So in here we have 3 types of requirements. One is general, -all, one is for documentation, -doc, and one is for tests, -tests. And it can be easily seen that PyTest, PyTest-conf, and mock are from requirements test, and the other from other. Okay, so we know what requirements we have. Great. Okay, so now let's run FawltyDeps on this project and see what information we can have. So this is command FawltyDeps run on this project, and we have 2 information, that there are some imports that appear to be undeclared, and there are some dependencies that appear to be unused. So let's deal first with imports that appear to be undeclared. Of course, FawltyDeps comes with a lot of knobs, so you can adjust the display, adjust the verbosity, a lot of other stuff. So for example, you can inquire more of the project you are in right now and see in which files, in which line the particular dependency is used. Okay, so let's start with NumPy. Well, it looks like NumPy is really not declared anywhere, but let's try it. Let's do some old school grep stuff. And well, it is not declared. It's just in sample, project, and some test. So yes, great. We found undeclared dependency, NumPy. But that's not the end. It's again them. Why it's not the end? Because if you run FawltyDeps, you do not want to have all this information every time you run it, even though you install those NumPy library. So setup tools usually comes with your PIP. That's why we do not want to include setup tools into display of undeclared dependencies, because it's usually just there. So what can we do? As you probably agree, programmers are rather lazy creatures, and we do not want to do things multiple times, and if we have to do it twice, we would probably automate it. And that is why we provide generate tom config option, in which the configuration for your PyProject tom is generated for you. You just have to fill in the gaps. So you just have to take it, copy it to PyProject tom, and you will be good. And FawltyDeps will be run on this setup. Okay, so yes, great, we have it. So for the setup tools, we added under ignore undeclared, because we do not want to see it anymore. We run FawltyDeps again, and it disappeared. Okay, that's what we expected. So basically what we do right now, it's a setup, just like we do setup for linter, because we like some suggestions and some not really. That's the same with FawltyDeps. You have to adjust it to your project. So the next thing that appeared to be an unused import is YAML. But it's not really, because there is PyYAML in the dependencies. But we did not have enough source, we did not know how to map PyYAML to YAML. So that's a reminder of what can we have from the mapping. And we have 3 options how to do that. First and simplest, I think, would be just to install PyYAML or all the dependencies that are marked as unused in your virtual environment, and then the mapping will be done for you. Second is point to the virtual environment when you know that PyYAML is installed. And the third one is to add a custom mapping, so the one that takes precedent over any other mapping strategy. So that's the one I chose to show you right now. And at the bottom of the slide, you can see tool FawltyDeps custom mapping. And in here, you can define your own mapping. So just to put it there, you can also use some file for doing that. So custom mapping file is just above ignore undeclared. Okay, so we run FawltyDeps again. And what do we have? We have NumPy, which we agreed that is not declared, and a lot of other stuff, which we do not probably want. Why do we not want it? Because those come from requirements doc and requirements test, and we don't want it. So we put them in under deps, we put only the requirements file that we want to use for the run of FawltyDeps, and under code, we narrow down the code that we search only to pep folder. And that's the main flow that we anticipate people will be doing and that we do ourselves in the project that we use FawltyDeps. Okay, so now we run FawltyDeps and we only end up with NumPy because all those other dependencies that were unused disappeared. And we add NumPy and we get an information that there is no undeclared or unused dependencies detected. And from that point, we have the whole setup for our project with FawltyDeps. And if we add or remove something and we run FawltyDeps on it, it will only tell us about the things that we forgot or declared too much. And just a reminder, where is our GitHub page and the blog post which says about exactly what was this history and how you can use it in your own projects. Thank you.
Thank you, Maria. So now we do have some questions. Can you use it as a pre-commit hook?
The same way you can use any other linter, I think. So it will not fix your problems, but it will say that there are problems. And yes, you could use it like that.
Okay. Does it work with _import, importing packages defined as strings?
No, that's the same history as with importlib function.
Don't you think that tool like this should be built into Python by default, like for all set of tools?
Yes, that would be great, but that's the same issue that, for example, MyPy or PyWrite. Why type checker isn't built in Python anyway, in the first place? That's the same question, because you can have different kind of providers of your packages, so it may not be that easy. And also, as I told at the beginning, there are some problems with things that you have to evaluate to figure it out. So in some cases, you may not be able to get the answer that is wholly true, because you don't have this information. Maybe that is why it's not there.
Okay. We have a comment. So Python dependency management is a bit messy. So so many different ways to install requirements and manage environments. Is it the weakest spot in Python now?
I don't know if I am qualified to say what is the weakest point in Python right now, but what I must tell you, that when we started this project, we thought, well, maybe it will not be that easy, but maybe not nobody cares, but there was not a lot of things going around this direction. And then we discovered that there is a lot of discussion around this subject. So it's being discussed. I don't know if it's a weakest point, but it's definitely an interesting point.
Okay, thank you. How does FawltyDeps compare to PyCharm built-in default dependency tools?
I would have to know how exactly PyCharm dependency tools work. Because from what I understand what linters do, for example, in this kind of situation, they just default to virtual environment they are running. So I suppose that PyCharm built-in dependency tools will do something similar. And usually, I don't know, maybe someone on this, maybe you know, if this dependency tool that is built in PyCharm also gives you unused dependencies, because there is a lot of tools that does undeclared dependencies, and also just as you run linter in your virtual environment, it will be highlighted, but unused, not so much.
Okay. What if we want to fix version of package using requirements, but we don't use this package directly, but it is required by other package?
Okay, that's a very good question. We had discussions around that as well at the very beginning of the project. And in that particular case, if you don't use it, you treat it as a part of your FawltyDeps setup in your project. So you have to add it as ignored deps, I think, yes.
Can Faulty detect unused local packages imported?
Unused local packages. Ah, I see. Okay, so you just put import something, but you never use it. No, it cannot. It was not. It does not go that deep.
Okay. Is it support pipe environment like pipe 5 and pipe file lock? Does it support it?
I am not really sure. I would have to check this. I know that we had some issue with pipenv, but I do not use it, and we did not test it thoroughly on this environment.
Is it able to detect that an imported function is not available in current declared dependency, but is available in newer one or any other?
Sorry, I have to read it to myself once again. Declared available. I see. Okay, about function, not. Because, again, FawltyDeps does not go as deep as to understand which function your module export. But if you happen to have a module A that in previous version exported my A, and in the next version it exports my B, then it will be figured by FawltyDeps.
Okay. Are there plans for adding analysis for outdated dependencies, or is it outside of the scope of the project?
Analysis of outdated dependencies. So like the one that I mentioned just right now? Maybe the... No, for this one we did not have a plan to do. But again, as I told you, if there is some discrepancy between what you import and what is exported, it will be found.
Okay. And how fast is it?
We do not have benchmark, but recently we added a traversing strategy for all the files. So we traverse all the files in the project only once and assign if it is a candidate for being, that imports can be there, or is it candidate for parsing requirements. So it just runs once, and then those are basically generic Python function like abstract syntax tree and some kind of parsing of different requirements files. So that's a good idea to have this kind of benchmark. I'll add it. But for like a regular project, it's few seconds. So it's not like 10 minutes. It will not. Few seconds is for some bigger projects because it has to, it has to parse to those abstract syntax tree all your code. So if you have weird code or you forgot to exclude virtual environments from it, then it will take longer.
Okay. So someone really wants to know. Someone really wants to get contact to the author of the logo because it looks amazing. So can you provide that info to the person PG?
Yes, of course. The logo was created in like 10 minutes in GIMP by Johan.
Okay. Is there any integration with other dependencies tools? Example, for known security vulnerabilities detection, or do you just need to launch them separately?
Right now, you need to launch them separately. We do not plan for those integrations, but as I say, we are open to improvement suggestions. Please post it to me or to GitHub issues.
Okay. Can we specify the entire directories that can be ignored, like abandoned build?
That's also a very good question, and we right now support ignoring directories that are in git ignore, so that's automatically done. And I don't remember if we already implement this feature, but we have it on our list pretty high, if not implemented, just to add to ignore. Just like you add code and deps and you specify which directories and files you want to search, just the like similar situation but with ignored. As I say, if it's not already done, it is on our list.
Cool. Were you inspired anyhow by Sid isort config library by Asotil?
No, this one I did not see. We searched a lot of similar libraries and tried to understand how different people approach the same problem, but this one we did not explore.
Okay. How about scoring and cache use history, like Pylint? Like in Pylint.
Ah, okay. Scoring is interesting. I think we did not have it in our pipeline anywhere. No, those features are not there yet. Let's say like that.
Okay. And the last one is, are there any plans to rewrite it in Rust?
We would probably want to, given the profile of our company. So it would be fun. But the first step would be to stop using Pylint, which is in a lot of places very annoying, and start using Graph. So if it is a step forward to Rust.
Okay, and that's all the questions. Thank you, Maria. That was a great
you.
talk.